medulla. So from this diagram it is very evident that osmolarity keep on increasing from cortex to the interstitium. The only reason for that one is the amount of NaCl or the electrolytes which are present in the interstitial medullary region, they keep flowing out or moving out from the ascending limb of loop of Henle, so that osmolarity keep decreasing up to the DCT. Osmolarity decreases from interstitial medullary region to the DCT. What happens from PCT, that is from the proximal convoluted tubule of the cortex region into the interstitial medullary region, it keep increasing. So in the descending limb of the enlaced loop, osmolarity keep increasing from 300 to the 1200 up to the medullary region. But in the ascending limb of the enlaced loop, osmolarity keep decreasing. With respect to that vasa recta, in the descending limb of the vasa recta, this is what the descending limb here. The descending limb of vasa recta, osmolarity keep increasing up to interstitial medullary region. But in the ascending limb of the vasa recta, osmolarity keep decreasing. Means the osmolarity in ascending and descending limbs of the vasa recta and then the enlaced loop are vice versa. Means they are opposite to each other. This counter current flow of the fluid with the respective osmolarity only causes concentration of the filtrate from 300 milliosmos to the 1200 milliosmos. So which fluid present inside this enlaced loop? Filtrate is present. Its osmolarity increases from 300 to 1200, from cortex to medullary region. That's it. Okay. The direct statement regarding the increase in the osmolarity is that osmolarity increases from 300 to 1200 milliosmos per liter from cortex to medullary region. What is responsible for that one? Close proximity between enlaced loop and then vasa recta and counter current flow of the fluids in them. So only the amount of NaCl which is moved out of the ascending limb of the enlaced loop will carried by the vasa recta and returns it into the descending limb of the enlaced loop. Okay. Along with that one, along with this, what happens? And small amount of urea is also return from collecting duct into medullary region, into interstitial medullary region to increase osmolarity. So here we can represent that urea. So small amount of urea which is returned from the collecting duct into the interstitial medullary region, that also plays an important role in increasing the osmolarity in interstitial medullary region. So this is what the counter current mechanism of concentrating the filtrate. Yes. So in PCT, isotonic to blood plasma. The filtrate in PCT is isotonic to blood plasma. Same filtrate when enters into the descending limb of the enlaced loop, it becomes hypertonic. Why? Because water moves out. Only electrolytes will be left inside that one. So it becomes salt concentration increases, so it becomes hypertonic to blood plasma. What happens in the ascending limb of the vasa recta? Ascending limb of the, what is that one? Enlaced loop. So what happens there? Again it becomes hypotonic. Why it becomes hypotonic to blood plasma? Because water remains in the ascending limb of the enlay, but electrolytes move out of the ascending limb of enlaced loop. Then what about in DCT? So when it arrives at the DCT, again it will be isotonic isotonic to blood plasma. And what about in collecting duct? So when such filtrate reaches the collecting duct, now it is called as urine. Now it is called as urine, and this urine will be hypertonic to blood plasma. Why it will become hypertonic to blood plasma in collecting duct? Because water is being absorbed by collecting duct. So only it will become hypertonic again. What about in case of at interstitial medullary region? There isotonic only. Again they will become isotonic. Okay, this is also important for the NEET examination. Any doubt in this one? So when the filtrate can be called as a urine. The filtrate after getting entry into the collecting duct only, it is called as a urine. And when filtrate enters into collecting duct, then it is called as urine. So how much concentrated the urine is when it is being released out of the excretory system? And the urine is 4 times concentrated than the initial filtrate formed. This urine is 4 times concentrated than filtrate formed. So this numerical is also very important for the NEET. How many times concentrated the urine is with respect to the filtrate means 4 times concentrated. So this is only regarding the counter current mechanism of concentration of the filtrate. Any doubt in this one? The next is very important one. That is nothing but the control of renal activities.